So today we are going to cover section 7. We are going to learn how to find the volume of pyramids and cones. Now, a pyramid, if we want to think about it, is sort of like finding the volume of a prism, but we're going to be cutting part of it off. So like, for example, if you took this pyramid and this square pyramid and you put it into a cube, really what we're doing here is we're shaving off like 1/3 of it. So what we're going to see is, in the case of the volume of the prism, remember it was capital B times H. For the pyramids, it'll be the same thing, but we're going to multiply the answer by 1/3. And what's going to be easier for you to do is just divide the answer by 3. And again, if we're not using a calculator, you would just simplify the fraction, unless it divided evenly by 3. And in the case where we have a cone, think of a cone as a cylinder, but it's cut off. So here's our cone. Remember the cylinder, so if we put it inside, it would fit inside. So it's sort of like a prism, but a circular base. Okay, so it's sort of tied into the same thing. We're going to do the same formula we did for the cylinder. Remember, it's still capital B times H. But remember, for the cylinder, it was pi r squared times height. For the cone, we're just going to put 1/3 in front. So they're very similar. When you're doing the homework tonight, most of the dimensions are given to you. We're not going to have to create any special right triangles. However, in the notes today, we are going to have to create some 30, 60, 90 triangles in order to find apophthegms or to find the radius or a side length or something like that. So we will be using special right triangles in the notes. The homework over the weekend, the practice A, isn't as difficult as the notes. So I haven't looked at the practice B yet. Practice B may look more similar to the notes, where you might have to use special right triangles. So our first slide, it's talking about what a regular pyramid is. Okay, so when we have a regular quadrilateral pyramid, we would know that the base in a regular quadrilateral would be a square. And if it were a regular triangle, then our base would be an equilateral triangle. So an equilateral triangle if it's a regular triangular pyramid. So know that when it's a regular figure, all sides and all angles are congruent. Whenever it's a regular polygon. Know that if I were to draw a square pyramid, and I'll try to draw a 3D figure here. Let's see what we can create. I'll draw a triangle first, then maybe another triangle over here. And let's draw in some 3-dimensional things, see if we can. And then you would draw in the height. And the height is always going to be indicated by that right angle. So if I said this was a square pyramid, we would know that all of our lateral faces here would be congruent isosceles triangle. Okay, and then down here, all the bases would be the same, and it would be a square. So this would be a square pyramid. And remember, all of our lateral faces, these things on the sides, maybe I'll highlight it, would be congruent isosceles triangles. Remember, your altitude meets the base at its center. So this is the altitude that I drew in right here, which is also known as the height of the pyramid. When we cover surface area, we'll be using the lateral or the slant height. The next one is theorem 11.9, and it's the formula for volume of a pyramid. So again, similar to what we saw for the prisms and the cylinders, capital B times H, but the difference here is it's 1/3 of it. And you can either, if we're using a calculator, just multiply your base times height first, and then divide your answer by 3. Now, if I ask you to leave it in simplest fraction form, if it won't be divisible by 3, then you'll just leave it as a simplified fraction. Next slide then. The next slide is the volume of a cone. So same thing, remember I showed you the cylinder on the first slide. The cylinder was pi r squared height, but when it's a cone, we're cutting 1/3 of it off. Here we go. Here it's asking us to, we have a regular square pyramid, which has base edges of 6 centimeters. So in here I'm going to put that each one of these sides is 6. And again, I'm not going to make you guys draw figures on the quiz. I know some of you are not good 3D drawers, just like my wonderful pyramid here. It's kind of rough. So here is my square pyramid, and I can see that all of these edges in here on the base are 6. It also is telling me that I have a lateral edge that's 5 centimeters. So my lateral edge is going to be right here, and this one is going to be 5. It wants me to find the volume. Remember, the formula for volume of a pyramid is indicated by 1/3 the area of the base times the height. Now, finding the area of that base is easy because it's a square and all I have to do is 6 times 6. So my base is actually going to be easy. I'm just going to do 6 times 6, and the area of the bottom will be 36, and these are centimeters squared. What's going to be the challenging part is finding that red height that is right at the center of my square. And there's 2 ways that I can go about finding that height. Yes. Draw a triangle and draw some lines up. And I know that it is regular. Notice its perimeter is 12. So what would each side be if the perimeter is 12? 4. So the base here, each one is going to be 4. I'm actually going to change this problem and say that it's not a slant height, but it's just a height to make my problem a lot easier.
So you're not going to do a slant height, and the rest are going to do is just regular heights?
More than likely. Okay, so this is 9. That's how the homework is tonight. The homework, they're not giving you slant height, they're just giving you heights. Okay, so here I'm going to find the area of the base. Now, notice I don't have the height of the triangle base, so I actually have to use my 11.3 information. So I'm going to redraw my base over here. And notice it's regular, so I know each one of my angles is 60 degrees. And if I were to draw in the altitude, notice now I'm going to talk about just one side of my triangle. And I've bisected this 60-degree angle, so actually up here is going to be 30 and then 60 over here. Because I bisected the side length, this is 2. My hypotenuse here is still 4. And because it's a 30, 60, 90 right triangle, I know my altitude is going to be 2 radical 3. Because remember, this is A, this was 2A, and this is A radical 3. So now that I have the height of the triangle, now I can do the formula for area of a triangle. So the area of the base can be found by doing 1/2 little b times height. So base times height. So 1/2, the base is 4, and my height was 2 radical 3. I'm going to simplify. Before I multiply, I could divide this and make this a 2.
The base is the bottom line, right? Like the bottom line?
Yes. So then the base is the bottom triangle. And the bottom line for the formula for the base is going to be this whole thing, not just the 2. So I actually have to put this back in here. Okay, so in this case, because it's equilateral, the base, it didn't matter. All the sides were 4. So the area of my base, my capital B, because remember the formula is 1/3 capital BH. So right now I'm working on capital B. And capital B ends up being 4 radical 3. So that's the area of the bottom. So now I can plug it in to my original volume formula because I know the height, it's 9. So 1/3 times 4 radical 3 times 9, and that's going to give me the volume of this triangular pyramid. I could simplify, make this a 3, and then multiply what's left, and 4 times 3 is 12 radical 3, and these are centimeters cubed. Over here, this area was centimeters squared. And I know the height of it. This is supposed to be hitting here in the center. So this height is 6. And I know the radius, which is going from the center to one of the sides, is 8.
Wouldn't the height of the base be 16?
The height of... Still doing the same formula, 1/3 capital B times H. In this problem, my capital B is a triangle again, so it's going to be 1/2 the base times the height. And notice the difference between the uppercase B and the lowercase b. Okay, uppercase B means area of the whole bottom, and lowercase b is just the base length. So I'm going to pull out my base so I can look at it a little bit more clearly. And I'm going to flip it around and show it this way. So right here, I know a radius is 8. And that's what I'm working with so far. I can put in some more. I know I have a central angle here of 120 degrees. And I can go ahead and start figuring out my triangle here. Yes.
How do you know what the central angle is?
Because you take the number of sides and you divide that into 360. So I've got my 120 degrees. I'm going to, this one I'm going to highlight, so I'm taking this thing out. So here, I am going to draw in the altitude. And this is 120, so now the 60 is up here. So now if I work with that, 60, 30, 90, and I can see that my hypotenuse here, this 8, is here. So if that's equal to 2A, and then if my A is over here, then this is my A radical 3. So to figure out what A is, divide by 2, so A equals 4. Then this side down here is going to be 4 radical 3. So my side length here is going to be 4 radical 3 plus 4 radical 3. This whole side is really 8 radical 3. Find the area of that triangle base. I'm not going to actually find base times height. I'm actually going to use my volume of a polygon, which is 1/2 ANS. I can use that one. And I can see here that the side length is going to be 8 radical 3. And I can also see that I have an apothem of 4. So if this is 8 and this is 4, I could do 8 plus 4, and that's going to be my apothem. So my apothem right here is 4, which was right here. So I'm going to do 1/2, 4 times the number of sides times my side length, which is going to be 8 radical 3. Can simplify this, and I will get 2 times 3 is 6, times 8 is 48. So the area of my base is going to be 48 radical 3 multiplied by the height, which was given, times 6, times 1/3. I could simplify the 6, make it a 2. So the final volume of this pyramid is going to be 96 centimeters cubed. Also found the area of the triangle by doing the 1/2 base times height. And just remember that you had the apothem here of 4 and you had the radius of 8, so you could have gotten the height of the triangle to be 12 and then multiply it by the base, which was 8 radical 3. And I think you can get it similarly that way also. But I just went ahead and used what we learned in 11.3. Next one. Now we're going to use the picture to find the volume of this cone. Okay, they're giving us a slant height again. So we're going to find the volume of the cube. The first thing we need to do is find the radius length, because I need to find the radius, so I could do pi r squared. Once I square 12 and multiply it by pi, I get the area of the base to be 144 pi. Then from there, I'm going to plug it into the 1/3 pi r squared height. And once I simplify, the 3 and the 144 turns into 48, and then multiply it by the height, which was 13. And 48 times 13 is 624. And I'm leaving it in terms of pi, so 624 pi meters cubed. Let's see, so I'm gonna draw a cone, dot, 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 circle it around. I need to put in a height. Remember, the height goes from the top vertice to the center. And this height of the cone is 12. It has a radius of 6. And then we also have a cylinder. And it said that it has a radius of 4. It wants us to find out, in order to hold the same amount of liquid, what would the height have to be for my cylinder? Now remember, with the cone, we've taken like 1/3 of it away. So if you get a question like this on the quiz or the test, know that the height of your cylinder is going to be smaller than that, because it's going to hold more volume than the cone. So we're going to first calculate the volume of the cone. And then once we get that answer, we could set it equal to the formula for volume of a cylinder. And then work backwards to find the height. So for the formula for volume of a cone, remember it's 1/3 capital BH. But remember, for the cylinder, it's just BH. So here I'm going to first do the cone. I have all of my information. I don't need to do any kind of special right triangles. So 1/3 pi r squared times the height. Again, the pi r squared is the capital B. It's the area of the bottom. So 1/3 pi times 6 squared times 12. I could simplify diagonally here. I could make this a 4, and then 36 times 4 pi, giving me 36 times 4 is 144 pi for the volume of my cone. Now what I'm going to do is I'm going to use this formula, pi r squared height, and instead I'm going to put V, I'm going to set it equal to 144 pi. Put in the pi, my radius is 4, and my height is unknown. So 144 pi is equal to 16 pi height. I now have to get everything away from the h, divide both sides by pi, And then I have 144 equals 16H. Divide by 16. And I get a height of 9 centimeters. So the height of the cylinder will be smaller than the cone, yes.
Why did you put the 144 equal to it?
Why did I?
Yeah.
Because it wanted to find the minimum height of a cylinder that would hold the same amount of liquid. So the volume amounts are going to be the same. So I already knew, by following the formula for the cone, I found out how much liquid or how much volume, how much liquid was in the cone. And I needed to put the same amount of liquid, the same volume into the cylinder. So my cylinder is going to definitely be shorter because it's got that gap, where you cut off the cone, that 1/3 part. It's got that it can still fill with liquid. So that's why it's shorter. And it's actually skinnier. It's got a smaller radius. So the cone's actually wider or rounder than the cylinder.